Hi everyone, this is Tom Cherryholmes with the next video in the Amiga as a Workstation series. Now that we've actually powered up our Amiga, run some demo applications, and been sufficiently impressed, we figured that it's time to tear into the development kit that Commodore sent us. In our case, it's a set of 3 disks, one disk containing our C compiler, which we will use, another disk containing Metacomco's macro assembler, which we will not use at the moment, and another disk containing a ROM-based debugger called ROMWhack. These are all intended to run under Workbench and Kickstart 1.1. So with that, let's go ahead. In order for us to actually take and use what we have here, we actually need to take and peel open our manuals that we got with it, and one of the manuals here is has a set of appendixes to get started with Amiga C, and it will give us everything that we need in order to set up our C development system. You'll see that we need a couple of blank diskettes, the original C-DEVEL master diskette, the original Workbench diskette, which we will duplicate, an Amiga 1000 computer, which we have, one external 3.5-inch floppy disk drive, which we also have, 512K of memory, which we also have. I apologize ahead of time for what is obviously OCR errors in this file here, but it actually allows me to take and search through it and do searches inside this particular manual. Otherwise, it's okay. So the first thing we actually need to do is we need to take and boot up our copy of Workbench. We'll do that by going into our emulator here, UAE, loading up our configuration, the Amiga 1000, okay, and then going ahead and placing our Workbench disk into the drive. So we have Workbench 1.1, boom, okay, great, and we have, let's see here, is this the... Make sure. Okay, make sure we put the right Workbench disk in here. Okay, great. Since we still need to boot from the Kickstart disk, we do need to boot from that. Apologies there. Let me get situated. Since we still have the Bootstrap ROM in and we don't have Kickstart in ROM yet, we still have to take and boot our Kickstart off of disk. In a few moments, it will ask us to insert the Workbench disk. So, we oblige. Come on there, buddy. There you go. In a few moments, Workbench 1.1 will be up and ready for us to use. So now we have our Workbench disk here, and if I now take and insert our C-CLI disk, this is a blank disk without any formatting on it. Workbench will have an issue with it. Okay. We don't know what this is, so we need to take and initialize it. Or actually, we really don't, because we can immediately take and copy Workbench directly onto it. So we put Workbench in drive 0, destination disk in drive 1, we go ahead and continue, and within a few moments, we will be copying our disk here. And as you follow the steps here, you'll realize that it's asking you, once that this is done, we'll go ahead and rename this disk from copy of Workbench to C-CLI. But this will take a few moments. One of the things that I am trying to do here with these particular series of videos is to demonstrate how long these things actually took. So I'm not editing anything out. The long pauses are here because back in the day, we had to wait for things, for everything. Formatting disks, compiling software, waiting for people to test our software. It's just the way it was. Interesting thing here, because Workbench is fully multitasking here, you'll see that the Workbench still reacts with the disk copy happening in the background. It doesn't pause, it just continues going on. And in fact, if I had another external disk drive, I could use it while the disk copy was happening between the other two drives. But we'll wait for this to finish nonetheless. Almost done. Disk copy is finished. It will unmount and then remount the drives. And we'll see that we now have a copy of the Workbench diskette right here. All we have to do now is rename it. Select the disk, right-click menu, select rename, and then we just kind of go ahead and relabel it. We're going to call it something completely different. Since this is going to be what's called a CLI disk for C development, we'll call it C-CLI. The disk is renamed, and now we need to actually boot off of this particular copy of the disk. Since I can't press Control-Amiga on this particular keyboard, I will have to do a hard reset and reload Kickstart back in as well. I apologize for any inconvenience this may cause. Again, Kickstart loads, system reboots, and we get the opportunity to replace with our C-CLI disk. If you change the disk fast enough, you don't see the Workbench or Kickstart icons. You see right here, we are doing just fine. Okay, so now this is actually set up, but we need to take and do a little bit of housekeeping before we start up. So now we've put our originals in a safe place, we booted our copy, and now we open our C-CLI icon to indicate that it's exactly like the Workbench disk that we just copied. I need to go into the Preferences tool now, as it states right here. We need to make sure that two things are set. We need to make sure that the CLI is turned on so we can use it, and we need to make sure that the text is 80 columns. In both cases, this is exactly what the case is. Sure, no problem. But we can also take the opportunity here to take and do other things as well, such as set colors, maybe set a custom color palette, who knows? It's all up to you. Maybe we do. Maybe I want something that's a bit more green. Maybe I want something a bit darker blue and higher contrast. It's fine. We'll go ahead and set it. That's okay. With our stuff set, we save our results, and they're instantly available to use. Now, what we need to do at this particular point is go into the system folder. If we hadn't set the CLI on, we wouldn't see this icon at the bottom left, the CLI icon. This is the command line interface, and it is another reason why the Amiga can be considered as a professional workstation. Because in addition to the graphical user interface that the Workbench provides, Intuition and the Workbench provides, we also have a fully featured command line interface into Amiga-DOS itself. Not only can you launch a particular single CLI window like this, if you need to, you can launch another one. It's a completely separate task with its own execution environment. It multitasks again. If you don't need a particular CLI window opening anymore, you can use NCLI to close it. If you want to create a new CLI window from the CLI itself, new CLIs will do the job for you. So you can see. But for now, what we need to do, we need to kind of push this over to the bottom so we can see our disks a little bit here. And I'll kind of just close these off for a little bit just to keep this open. And I will now take and put in my C development disk. With the C development disk in, we'll see it pop up on the Workbench here. And there's really not, from the Workbench's perspective, there's really not much here that you can see of use here. You've got a little bit of some development L-receive tool that can be used by the cross-development tools to shuffle binaries across. But it's telling you right here, you need to use the CLI to access C. Okay, fine. Close that window. And what do we need to do next? Well, now we need to actually take and go on to drive 1 with the CLI to DF1. And we need to go into the S directory here. And you'll see that there is a script called MakeCLI to make our custom C command line interface disk. Let's have a look at it. We're not going to change anything here. We're just going to take the defaults as they are here. If you do decide to modify this particular file, I would suggest saving it onto your Workbench disk, because there literally is no space left on this particular disk at all. But you can see that we're deleting a whole bunch of files that we don't need from the Workbench disk. We're deleting all of the Workbench utilities. We're deleting all of the additional fonts, drivers, things, so that we can have enough space in which to compile some code. We need to do this because there's no hard drive yet. And finally, we take and create a replacement startup sequence that makes sure that we have stack set to a high enough value for the compiler to run well enough. So now this is here. We'll go ahead and hit escape to hit the asterisk menu Q. And by the way, that was the full screen editor called Ed that Metacomco provided Commodore-Amiga. They actually provided two editors in this case, Ed and Edit. Edit being quite literally a command line interface, basically a line-based editor. Apologies. But I digress. Let's get back to what we need to do. So we need to run this, because we've made a backup of the Workbench, and you see that we're going to be destructively removing things from this Workbench disk. Aren't you glad we backed it up? We need to execute the script to basically trim the fat from the Workbench disk. It's actually important to understand that if you use, for example, the Commodore-Amiga Forever editions of the Kickstart and Workbench disks, you will find that because Commodore did not renew its licensing agreement with Soft Voice Incorporated, which provided the voice synthesis software that's used in Amiga DOS, and because it is still an active company, that the narrator device and the translator library are not present on the Workbench 1.1, 1.2, 1.3, 2.0 disks. Just a fact of life here. So don't use those disks unless you decide to take and modify MakeCLI to not delete those files, because those files not existing will cause an escapable error. So anyway, we're cleaning everything up, and in a few moments it will take and alter the startup sequence. And once this is done, we'll be back in the CLI. And we're not quite done yet, because after this is done, we need to take and do a little switcheroo to move the C compiler and the linker and some of the associated utilities onto this C-CLI disk that we've just created. Okay, now we're done. Now we're on to section 2 here. We need to actually make sure that the C-CLI is there. Okay, great. C-DEVEL here. Okay, we've done the disk copy of this already. I did that off screen, so to speak. And we are going to take and copy all of the files in the C directory, which are the compiler commands and the associated utilities. We're going to place them in our C assignment, which goes to our C-CLI disk here. In fact, if you want to see where your assignments actually wind up, run the assign command, and it will show you what's actually mounted and where. You saw that we had a set of assignments here. Sure, okay, fine. Let's go ahead and make that a bit bigger. You'll see it doesn't have any command history, but if we run this again, you'll see that by default we have a series of assignments, including the old WB assignment that the script actually did. So now we want to take and copy to the commands directory so that they're available. A link is the linker. This is the Amiga-DOS linker that was provided by Metacomco. It's used for both C and assembler development. Snoop is a debugging tool. Okay, fine, read, etc. LC is the front end for the Lattice C compiler. OMD is the object, basically the object file disassembler. It lets you basically pick an object file apart to see what's inside of it. Object dump just basically lists what's inside of a particular object file output by the compiler. LC1 is the first pass of the compiler. If you're familiar with how things are done on Unix, this is analogous to CC1. And then we have the second pass of the compiler. The first pass of the compiler will take and compile the C code as is and not attempt to take and do any forward or backward resolving. Basically, the whole point of it is to take the C compiled code and turn it into a series of intermediate bytecodes, which Lattice called quads. And LC2 takes those quad files and turns them into object files, which can subsequently be linked. ROMWAC is the debugger that Commodore-Amiga wrote. Atom is kind of an unusual utility. If you look in the C manual, it's basically used to relabel certain hunks output in certain object files so that you can specify data segments to go into chip memory, for example, and so on. There's a whole bunch of nifty things you can do with Atom. But now we've got the commands already set up here. But we need to do one better. Remember, we've done backups of all of this, and now we need to take and delete all the stuff that is in our drive 1 here, because we need that space. Since we copied them over, we can just as easily do that. And because we made backups, we don't really fret about doing any of this. Always make backups, fellas. So now, pretty much, we're done. We have everything that we need, and everything is all set up, ready to go. At this point, we can take and boot this. Let's go ahead, throw our Kickstart back in, reset the system. And boy, I will tell you, the ROM-based Kickstart couldn't come soon enough. Okay, booting into our newly loaded Kickstart, C-CLI. C-DEVEL is in DF1 still. We go ahead and boot our C-CLI disk. And you're going to notice some things differently here. Of course, you'll notice that our color palettes and things have changed, but you'll see that it's now a CLI disk. No Workbench, and in fact, if you tried to load WB, there's no load WB to happen here, so there's no way to load the Workbench. But we have an optimized system here. And more importantly, if we look at info, we can actually see that we have 56%. We've got 45%, 44% disk space left. Yay! Okay, great. We're good to go. Now we can actually see if we want to take and build something. So now we can change over to our example folder. Now, the way you can refer to directories, you can refer to, you look at your assignments to see what all is here and what's all mounted, etc. You'll see that we have our devices, DF0, DF1, our printers, etc. You'll notice that we have a RAM disk here. Even though you didn't see it on the Workbench, it's not mounted there, there actually is a Workbench that you can read and write to that's very fast. And when we add more memory, that RAM disk is really going to come into its own. But until then, let's go to we can of course go DF1 examples, but we can also refer to it by its volume name. Same thing. And in point of fact, if we try to reference a volume or assignment that does not exist, the intuition will stop us and say, please insert that volume in any drive. We don't have it, so we cancel. So, okay, can't find foo. But there you go. If we look in our directory that we've gone to, the examples folder, we see a whole bunch of interesting bits and pieces of things. We see some example code such as speech toy, one.window.c, frags.c. We see the source code for 2 different startup segments. These are important because every C program needs an initialization segment to set up the system appropriately to execute the resulting C code. And Lattice actually provided 2 of these particular startup routines. A startup is if you're not using any Lattice or POSIX like routines. L startup is if you do want to use Lattice or POSIX routines mixed in with your Amiga stuff. So pick the right one appropriately. We also have a couple of scripts that help make things a bit easier, such as make to compile a C program, link to link an object created by C program, and of course MakeSimple, which combines both of those steps. If we actually take a look, we'll see that it wants us to take and compile our first program. Okay, we go into the examples here and we want to execute MakeSimple frags. Well, let's look and see what MakeSimple is all about. I can add MakeSimple. It is a script. And it has a few options that it can use. So you can put up to 3 parameters up here, which are three things that you want to take and mix and match together. So it takes and puts these as options for the first and the second stage of the compiler here. And it also helpfully, as part of the compile options, sets the include directories for you, makes it nice and easy to deal with. It tries to handle if the compile failed or not by the absence or presence of a quad file. And then it immediately passes over to the A-link, or the linker, to take and combine the startup file. You saw the Astartup.asm here in the examples folder. Well, the object code has already been compiled for you and placed in the lib folder. To link it with the file using the library lclib and libamiga.lib. lclib contains all of the basic lattice C functions and whatnot, while amigalib contains all of the functions specified in the ROM kernel manual, all of the Amiga specific stuff. So there we go. Okay, great. We're not going to modify this. I just wanted to show you what we're going to be running here. So we'll go ahead. Since this is a script, you have to use the execute command. Amiga-DOS is case insensitive. It remembers case when you store it to the disk, but you don't have to maintain that case when you're trying to refer to the file. So execute MakeSimple frags. We do not want to use the extender here because it will add those extenders for us in the various steps, in the various intermediate steps. So while it's doing that, we can take and look at some of the other bits and pieces. I'm going to take and do a new CLI and just kind of keep this guy in the background here. And I'm going to execute MakeSimple frags. And while that's going on, we can take and do something else. Amazing, isn't it? We'll just kind of take and maybe throw a little bit here. Who knows, really? We can look at some of the different examples in the folder, such as the frags example that we happen to be compiling. So this is compiling here in the background. And you can kind of see some of the interesting things that you can already see. The includes for the various RKM structures and references. But you'll also notice that this C compiler is actually old enough that what we are seeing here is ancient C, K&R type C. No ANSI C here at all yet. That wouldn't come until later, version 5 actually. So we have a little look here. Boom. We see some Amiga scheduled specific commands like forbid to take and tell everything to tell the multitasking to hold for a bit so we can access some critical internal structures, such as figuring out all the different heaps, all the different heap stacks and how big they are, showing them. And when we're done with that, the reverse of forbid is permit. And then we take and display them once we have them. So that's great. There are some other bits and pieces as well, such as one window, which is an excellent example of how we can do intuition programming. And I stopped it right here just in time here. This example was written by the great Rob Peck, who was the documentation writer for Amiga, actually predating their time with Commodore even. Much of the documentation in the ROM kernel manual is courtesy of this guy walking around to everybody's offices at Commodore-Amiga and making sure that he understood every part of the system. Lots of includes for various different parts of the system, intuition, graphics libraries, etc. And data structures, which you'll need to do things like create new windows and respond to particular events. And what you have right here is enough of an example to get you started with taking and writing a GUI application. There's really not much to it. It's really actually very simple, especially compared to a lot of the other GUI toolkits at the time, such as GEM or the Mac Application Toolkit. Handling of events, and so on. And you can see that we're happily picking and looking at other files, taking care of other things while the compile is happening. I mean, if I really wanted to, I could take and go right back around and use the text editor here to take and open up this particular file. Sure, no problem. It really worked, and it was absolutely surprised. It was very surprising how well it actually worked. Now, granted, there would be some better text editors to come in the very next few months. The port of Micro Emacs by Andy Finkel would be a good example of that, but that wouldn't be here just yet. Okay, say we make some edits, and when we're done, we take and quit. So when we're done with this particular, I'll just take and put it to the side. We might need it. I don't want to be blank. I don't want to be blocked. But we can see that the compiler went through both phases, created an object file, and now it is taking and running it through Metacomco's linker. And the result will be a file that we can run. Okay, linking is complete. We're done. Now we bounce back out to the CLI, and we can run the result. And what we'll be presented with here is basically a list of heaps inside the system and how big they are and how many of them there are, so you can count potential memory fragmentation inside the system. Our C compiler works. It creates a CLI application just fine. And in point of fact, now we can actually take and do this again. And we'll go ahead and compile one window here. Oops. Execute. Now, this is an example of a make script that really is very, very simple, extremely simplistic. It allows you to handle 3 files at most. If you want to add more, you need to either add more parameters to the script here, or you need to use a more complex particular tool. Lattice Make would be made available for the Amiga about 2 months from this particular period that we're dealing with right here, which is April of 1986 or so. So Lattice's editor would be, the Lattice screen editor would be ported, and the Lattice Make would be ported, and basically all the tools that make professional software development bearable, at least at this point in time, would be ported in short order, but they're not quite here just yet. Of course, because we have this other window open here, we can just continue to do something else. Like look at, for example, Astartup.asm. This would be compiled with Metacomco's assembler and would include everything needed to indicate where the C mains task would start any external functions that we would need, such as being able to open and close the DOS library, and so on. The standard program entry point, moving things in so that the ROM WAC can actually hook onto it if we want it to. We have to get exec library's base pointer, get the address of our task using calls in exec. And then we have to figure out, are we running from the CLI or are we running from Workbench, and do the appropriate thing in either case. But in any case, if we run from the CLI, we have to open the DOS library, find the command for our task, create any buffers, things that we need so that we can parse command line arguments, and so on. Of course, sometimes we need to be able to take and process information from pipes so we can create standard in, standard out, and standard error for C programs that we port, for example, over from Unix, which expect these files to exist. And finally, we take and call our entry point. Workbench has to be handled a bit differently. And we handle all of that here. Basically, handling any tool window arguments. If there's a file that got dropped onto us, well, we need to take and pass that along as one of our arguments as well, and so on. Finally, our exit function, which basically resets the stack where it needs to go, restoring it to where it was before this program was started, closing all the libraries, and doing all of the exits back to DOS. And so on. We'll go ahead and move this out of the way so we can wait for this particular part to finish. Once you've compiled the two example programs, they'll actually start giving you pointers so that you can take and compile your own programs. Use the built-in editors to take and create and modify your program. If you include any Amiga include files, you need to make sure they include types H from exec, which contains a lot of critical system structures. Compile using MakeSimple if the program's simple enough. And you can use them, you can copy them into your scripts directories so that you can just have them available everywhere so you can use them, no problem. It's also making sure that if you decide to do the speech toy example here, you have to do a few extra steps. And with these particular steps here is making sure that we have a large enough stack, which we do because we're running from the CLI disk. But we need to take and make the speech toy code itself individually using make. And we also need to take and make the custom mini main function that speech toy uses that will initialize the narrator device and everything before everything comes up. And then we need to do the link separately, which takes and links these two object files that we've taken and compiled up to this point. Finally, if you wish to run this from the Workbench, you also have to take and move the file into place along with its associated info file so that you can put it on a Workbench disk and load it from there. Let's see how we're doing over here. Darn. Yes, this is taking a while. We'll just sit here and wait. Since we're here, we can actually take, while phase 2 is happening here, we can do a little peek behind the curtain. and we can see some of the intermediate stuff that's happening before the object file is created, namely the quad file. You'll see that there is a one.window.q file. This is the intermediate quad file, and if you look at it, it would look like binary gibberish. This intermediate file is a certain size. It's 17 kilobytes in length. Now we're taking and doing the link. But we'll see now this file will be gone because MakeSimple will delete it for us. You'll see that one.window.q is gone and we have an object file in its place. Again, as a reminder, if we take a look at the lib directory that this thing sets up here, these are the individual libraries that the linker is actually looking through to get all the functions that we need to resolve against, either C functions for C standard functions, as in the case of lc.lib, or wrappers around the ROM kernel module functions, the ones that are in Amiga lib. And of course, we see the L-Startup and A-Startup object files that I referenced earlier. If we do a little list, we can see the sizes of these files and the dates for each of these files. You can see that these are, December of 23rd, just before Christmas of '85. Somebody was working up to the last minute. And it's very important to understand here just the simple act of having something that could multitask. Made using this machine, even though we only have floppy drives here and we have a 7 megahertz 68,000 here, it's still not bad to work with. It feels faster because I'm able to take and do more than one thing at a time. And in an age where most personal computers simply didn't do that, this was a godsend. We'll just kind of take and tuck this back a little bit. Whatever, bam, goodbye. Now we're done and we can run the result and we'll see our intuition program. And we can see right here, we have an intuition program. It's drawing graphics, doing line calls, etc. But it also has a console window here that is open. So the console window gives us two things. It gives us events that you deal with here, such as mouse selections, whether or not you do menu calls, etc. But it also echoes. Boom. And in point of fact, if I can take and run it in the background. maybe I want to run another one. I can. Just as easy. Here we go. 2 multitasking versions of the particular piece of software that I have here. And mind you, if you look at the source code for this particular application, there's nothing particularly special about making it multitask. Because again, each of these programs gets their own unique execution environment. Exec does all of the necessary work to take and multitask it. Intuition does all of the necessary resource multiplexing, talking to the graphics library, talking to the layers library, making sure that everything works harmoniously. So now here we are basically at the end of this video. We know that everything works, and now we can take and continue on to the next step here, which is designing our first particular application that we want to do, which will show us a heat map graph based on data that we import in. So until we get to that point, guys, as always, have fun.